Hello, everyone, and welcome to this session where I'm going to talk about how you can extend Spinnaker via the use of custom jobs. I'm Nirmalya Sen. I work for OpsMX, and I've been in the industry for quite a while, working in companies like Oracle, Cisco, and have been with Spinnaker for more than a year now and loving it and want to bring more of its capabilities to you guys. For the agenda today, what we're going to talk about is when and where this custom jobs are useful, talk about the Spinnaker run jobs, how you can use them, how you can pass the parameters back and forth between Spinnaker, the jobs, and downstream stages. And then, once you have tested it works and, if you want to convert it into a custom stage, how you do that. And then finally talk about other considerations. With that, let me spend 30 seconds on, on OpsMX, who they are. OpsMX is a leading provider of continuous delivery solution. We have people from companies like Netflix, Cisco, Oracle, AWS. We have 90 employees worldwide, 90 plus worldwide. And we provide, services like 24 by 7 support of Spinnaker, managed Spinnaker, and professional services like onboarding services or best practices around deploying Spinnaker. We are major contributors around the open source community. We have active participations in Spinnaker, Kubernetes, and Jenkins in the Jenkins community with lots of commuters, contributors, and contributions. With that, let's talk about the Spinnaker run job stage. And, we will go through a demo and show it how it works and all that. So Spinnaker has this built-in stage called run job. What you can do over there is basically run a Kubernetes job in there from Spinnaker. You can provide its manifest just like you do any deployment. You can provide the manifest to run as a text right in there or in an artifact that Spinnaker understands, which could be in Git or Artifactory, whatever is the supported artifact store that Spinnaker supports. And then, you could, if you need, even bind artifacts to that, like, if you have an incoming image coming in and you want to use that image to run the job, you could do that. So things, the typical bindings that Spinnaker provides, you can do that. And also you can capture the output from the run job. Output could be just capturing the logs, the console output of the job, and that's what we'll be doing. Or it could be an artifact, right? In your job, you could push the artifact to S3 or Git, and then make it available so that Spinnaker can use those artifacts in all the subsequent stages. And we will see this in a little bit more details very soon. One thing which I like to point out here is what we have noticed quite often is that Spinnaker caches the data from Kubernetes clusters, and if you see that your job stage is stuck, doesn't get the status back, enable live manifest in your account. That would ensure that Spinnaker is able to get the status of the job back and accurately reflect it. With that, let's talk about where this run job is useful. It's basically used to run some scripts. One of the ways, to run a script, which is basically the script runner type thing in Spinnaker, is execute something in Jenkins, right? If you have a script in Jenkins, you can make it invoke those scripts in Jenkins. What if you don't have Jenkins? Can you not do it? Yes, this is where run jobs becomes useful. Say you have to interact with a database. Your deployment process involves updating the database, running some upgrade scripts on the database, or updating updating some data in that. So you could do that via the scripts, right? That you can encapsulate and run it as a run job within Kubernetes. Or you could run some tests, right? You have deployed something, you want to run some stress test or functional tests, regression tests. How do you run them? If you have scripts, if you don't have Jenkins, package it in a run job and run it. Or you could even do policy checks. In one case, where they had requirements that, my Git approvals must have one person approving it, or basically the Git PRs must have at least one person approving it. So even if you got a Git trigger, you don't want it to proceed if that policy is not satisfying. So you could run some extra things which are not built into Spinnaker through these run job type things. In fact, we built some sort of a stage which uses run job that uses such policy checks with OPA, where these are written and available. You could use this in systems which are beyond webhooks, if you want to update tickets in Jira, or pull in content from Jira and use it in your downstream stages. Same thing with ServiceNow. So things that you want to do that goes beyond webhooks, you could use them in there. So these are like sample things that you could do. So basically, do some processing. Fetch some data, process the data, update something. So all those processing you can do using these run jobs, extending features which are not available in Spinnaker as first-class objects, including doing builds. Spinnaker is not a CI tool, right? The thing is that you leverage CI in Jenkins, Travis CI, Wrecker, whatever you're using. Use that. It's not a CI tool, but if you don't have those, you can use Spinnaker to do builds. And that's precisely what I'm going to do a demo today about, where I'm going to use Spinnaker to do a build and deploy. So, today we'll work through this scenario. So, there's a Git. When a Git change happens, it would trigger a Maven build. As you all know, there's no first-class support in Spinnaker on Maven. So, but there are containers available. That's what actually makes this run job very useful. Today, you have containers available for all these tools, actually. So we'll use a publicly available Maven container to build it. And we'll push the content to some, in this case, we'll push it to an NFS share. You could push it to an artifactory like a Maven build would do, right? And then we will create a Docker image out of our build. We'll use Canico, if you have used that, to build the Docker image, which will pull in the image from this NFS share. Like I said earlier, it need not be NFS share. It could be any artifactory source. Build the image, push it to Docker Hub. And then deploy that to Kubernetes from Docker Hub. So this is what we'll be going through and see how we can extend Spinnaker using custom jobs, right? Now, this is supposed to be a workshop. If you want to work along and see what's going on, you could absolutely do that. The requirements are you must have a working Spinnaker. How to set up a Spinnaker, you could go to this blog you could go to blog.opsmx.com and search for GKE LDAP and you'll get it. It's a little old in that it uses Helm too, but you can, if you are using Spinnaker, you should be able to adapt it to install a Spinnaker with authentication. And you need to have a Kubernetes account configured in your Spinnaker. Now, if you've used Helm to deploy Spinnaker, you're playing around, the Kubernetes account in which you deployed Spinnaker is set up as a default account in your Spinnaker, so you could do that. And finally, whatever I'm going to use is available in a GitHub repo under OpsMX Spinnaker Summit 2020, which is right here. Again, it's OpsMX. The URL is OpsMX Spinnaker Summit 2020. So what do we have here? Let's talk through them. We're using run jobs. And, I have a sample pipeline.json that you should be able to load in and try this demo. 3 things that you should change. There's a reference to an application, I think it's called Summit 2020. Just change that to whatever application you are installing that pipeline in. This source that we build using Maven, build the image with Docker and deploy. The source for that is available in the source directory. And this is the pipeline JSON that we have. There is a deploy manifest of the YAML that's used to deploy the simple application. There's also the Docker file that's used to build the application. That's all in there. You can look up about Canico that's used to build Docker images from within Kubernetes itself. You could read all about it. There is a prerequisite to use Canico, which is a secret that contains credentials to your Docker repository. So if you're using Docker Hub, you have to create a file, and that file is actually in here, this file config.json. I've not listed it out there, but this is pretty much like the structure of the file, where you say what is your Docker repository and the auth token to that, okay? And for Docker Hub, that auth token is basically base64 encoding of your user ID : password. And then you create a Kubernetes secret out of it. And we'll see how we pass that to your config JSON, to your pipeline. So that's all we need if you want to play around with it as we go along. If you want, there's some additional information like I showed. We have NFS where we actually store it. So if you want, there's this NFS directory that has little instructions how you can set up, your mini NFS server within your Kubernetes cluster. That should provide an NFS storage class within it. And then you can create a persistent volume claim that you can use in your pipeline. So this is the pvc.yaml that would do the persistent volume claim in there. There are also instructions to set up Spinnaker with the values.yaml. And I'm doing another session later on about installing Spinnaker using Helm, all the options in there, and I'll cover more details about how to install Spinnaker using Helm in that session. And if you want to enable authentication, this is the same link which I had in my slide too, where you can go and follow through how you can enable LDAP authentication in your Spinnaker. With that, let's look at our use case in Spinnaker. Okay. Let me let me just walk through this pipeline. So this is the same pipeline that is there. So let's look at the pipeline, understand the structure of this. Again, like I said, if you just use that pipeline JSON that's there and, create a new pipeline, go into edit JSON and paste that pipeline JSON over here, you should get a structure pretty much like this, okay? And then you can, if you want to play around, edit it, you could do all that stuff. So let's look at the configuration. So we have set up an automated trigger in Git, right? So you have to basically make sure you go and configure Git to send in the trigger. Like if I go and look at that, if I go to settings, if I go to webhooks, and if this is the trigger that I have already set up. If I go look at edit, I need to log in here. You can see I have basically set up a webhook trigger that delivers the payload to my gate as an application JSON, and only the push events is being sent. Okay, so I have that set up here. So I have that set up. I've said what is the repo type, which is the organization, which is the project, which is the Spinnaker Summit 2020, and I actually have a secret so that if that secret doesn't match, the trigger won't work. So I've set up a Git trigger. And again, I set up a webhook trigger also in case if I wanted to play around in there. Now this takes in one parameter. You could have more parameters just to show that. I take in the Git repo as a parameter, and I'm using the default value as Spinnaker Summit in there, so I use that. I'm not doing that, but you could also extract the repo from the Git trigger. And again, that is probably for another time, but we have pipelines where we will extract the parameter from the trigger that's received. So let's look at the first run job. Like you see, this is a run job, which runs a Kubernetes job as manifest. What you do here is you select the account to be used. I have only one account default. I'm using that Kubernetes account. And I'm providing the manifest to be run over here, right? So here you can see I'm using the Maven image that's publicly available to run this. And what I'm also doing is I have set up an NFS share. I'm basically mounting that as a volume on /workspace. Remember that image what I had over here? I'll go back there. When I do a Maven build, after the build, I push it to the NFS share, which is basically where I have mounted the workspace. And then the Docker picks up the built images from there. So what am I doing here? Workspace is the NFS share that's mounted, and I just have the little script that runs it. So I clean it up. The Git repo is passed in as a parameter to me, which is the parameter that I pass, right? It's an environment variable for me in my script, and this environment variable as the value, Git repo, which was passed in as a parameter. So I clean up the directory under there. I clone my repo, and then I do a Maven clean install of that. Right? I've done that. Basically, at this point, if this is successful, I would have built my repo using Maven. Next, I need to pass something back for downstream processing, right? How do I do that? I can have things like Spinnaker property underscore, whatever I give. The run job would process the log file and look for all these Spinnaker underscore property and make those values available as properties in any downstream process. Okay, so in this case, it's commit ID, and we'll see how commit ID is available in the downstream process. Okay, and what we are doing is in that process, we are passing in the latest head, basically the SHA for the latest head in the Git repo. I'm just passing it that, and I'd use that commit ID in subsequent downstream stages. There are other ways to pass in these values, and I'll come and talk about it in my slide once I'm done through this demo over here. So like we talked about, this will build an image, build the Git repo, and make the output available in the workspace directory. Let's look at the next run job. The next run job, it actually builds the image. It uses Canico like I talked about. So it's using the Canico projects executor to build it. And again, if you notice over here that I mount the same NFS, which I mounted in the previous stage over here in the same directory. Need not be the same directory, but I just mounted in the same directory. And to Canico, what I need to pass is the Docker file that should be used to build it. In this case, it is under workspace in the Git repo, Docker file. That's what's there, right? And I'm telling the context for the Docker file, whatever it is. So I'm giving it the workspace. So everything underneath it, it should find it. And then I'm also giving the destination where to upload it. So I'm saying upload it to Docker Hubs, Nirmalya /summit, and the commit ID. Remember the commit ID that we passed in from the previous stage? We're going to use that same commit ID here to build and publish the Docker image. Okay, and this is the thing I was talking about. We created that secret in Kubernetes, and this is where the Canico uses the secret to authenticate and push the images to Docker Hub. Okay, hope you all are following along with me till now. So what we have done till now is use run jobs to do processes that are not available as first-class support within Spinnaker. We built an image, we compiled our source, and we built our image and published it. And then finally, we want to deploy it to Kubernetes, which is the standard out-of-the-box deploy manifest that's available. Here, this is our standard deployment. Like you see here, this is the image, and it's the same commit ID from this build stage that it output that I'm using in the downstream stage to pull and deploy, right? So again, this deploy.yaml is also available. The whole pipeline is available in there. Let's try to run through this thing here. By the way, if you have any questions, you could post it in the chat. I'll try to take a look at it and answer the questions. And we'll probably have some time left towards the end to answer any other questions. Let's look at what it deployed. So this is a run I had done about an hour ago. Let's look at it when we ran this. Actually, what I'm going to do is, before going in looking at this, I'm going to trigger a build. It will take whatever, this minute, 28 seconds. And then while it's building and running, I'll walk through the outputs and all that. But before that, let's go look at the cluster. This is the output from my previous run. And you can see this is the load balancer associated with it. And if I click on this, I can see it's running on another port. I need to add the port there. There you go. OpsMX, congratulations. Welcome to Spinnaker Summit. let's make a change and try to push the change through and let it build and see how it looks. So, the comment is, hey, we don't like this blue background in Spinnaker Summit. Let's put in the purple background of Spinnaker Summit that's also around. So let's go make that change in our source and see the pipeline getting triggered. So I go there, I go to source and resources, public, and this is the index.html. And this is the style sheet that drives the Spinnaker Summit. And I'll just edit it right here in the UI. So let's comment out the blue background and bring in the purple background. It's done. I made my changes, and I'm ready to push it through. Change background to purple and commit the change. Nice. Let's go look at this here in our pipelines. And you can see that the Git trigger has triggered this pipeline. It's running right now, right? It will take about 2 minutes to get deployed. Till then, let's look at how it looks. So if you remember correctly, this is the build stage, which does a Maven output. I could look at the console output, and the pod is gone. So we'll actually have to wait for this to complete to see the output. That is Kubernetes cleaning up the jobs out there. So let this finish. While that is finishing, let's talk about the parameter passing we talked about a little bit. So how do you pass values for downstream processing? I showed you the code where we had the Spinnaker property underscore, and anything in there is available to downstream. We had commit ID over here, right? And that's available for downstream processing. What you could also do is have things like Spinnaker config JSON defined as a property. And you could have any valid JSON coming in, and that whole JSON at that time is available for any downstream to use. Any values that you write in the JSON is available in the downstream, right? So that's another way to pass it through, basically via logs. You output those in the logs, Spinnaker would parse the logs, find those tags, and make those available to you. You could also make them available as artifacts. What it means is that in your processing, in that run job, you would save it as an artifact in one of the supported artifact stores in Spinnaker, right? Artifactory, Git, it could be even an image, right? Like our image, we could have used that as an artifact. And then those artifacts could then be used in downstream stages. So when you do the processing, you basically, you saw there was an option to define artifact as an option. So you can then use those artifacts in downstream stages also, okay? So that's how you can pass values back and forth from, pass values downstream from your run job. Let's go look at this. This is completed. Nice. So let's go look at this. This is my build stage, and it provides me the console output. There you go, my console output. If you have used Maven, this output should look quite familiar with you, right? And if I go all the way to the end, you will see it tells me the build was successful. And it has written the jar to the targets REST app.jar. And this is where I'm passing the value back. Property commit ID is D58462. I did not read that out correctly. But the main idea is that, commit ID is available in any downstream processing. Okay, and we'll see that. Next was this build stage, right? If you go look at the console output, we will see that it ran successfully. And if we actually go and look at Docker Hub, this is my Docker Hub, and let's refresh this. This does not seem to be in the order I wanted. Let's refresh this again. I'm not sure why it came in that order. There you go. This is that same D586482, which was pushed by me. So it used this as the commit ID to push the content to Docker Hub. And then if I go and look at the final stage, which deploys it, it was successfully deployed. This is the replica set. I can look at its YAML. And if I look at the YAML and look at the image that got deployed, here is the spec. Here is that same image, D586482, that got placed in and got deployed. And the commit ID got it there. So it got deployed. So let's look at if it updated my website. Demos always doesn't work, but it does work this time. So you can see that it updated the background of that image. Let that go away, that share thing. Okay. So what you see over, or what you have seen, is that I can use run job to do any processing that I can do in a container that is not supported first class by Spinnaker. Okay. All the way from like even building Docker images, compiling, and then using those images to deploy. With that, let's see if there are any questions. Like I said, the chat's open, so you could definitely ask in the chat if there are any questions. Let's move on to the next thing that's there, which are custom stages, custom job stages, right? It basically does the same thing what you have done, and what I have found is that before you create a custom job stage, all your R&D you want to do, all your tests and trial, it's best to do with a run job, and make sure it's working before you create a custom job stage. Because what a custom job stage requires is that you have to add your changes to Orca local, and that requires you to restart Orca. Basically, you make the changes to Orca local. If you're using Halyard, you do a hal deploy apply, that would restart Orca, then your changes are available. So it's a little high cost iteration to find out or test or make the relevant changes to make sure it's working correctly. But once you have it working correctly, what a custom job stage does or helps you is that it shows up like any standard job in Spinnaker, right? Like this is called Maven build, and you can have descriptions, everything, and it can have its own parameters in there, right? And it hides all the details in there. So if I go back here and look at my other pipeline, that's what I did. So before I go in there, let's look at this guy itself first, the run job, build run job, right? You see all the details of the pipeline is exposed. If your end user sees it, they can make some changes here. Sure, you can lock the pipeline to prevent that, but your end users can see it and make changes. And if you want to hide all these complexities, you can basically create a custom job stage, which is what we have done here. This is the Maven build we are saying. Everything is hidden in here, right? And it just basically becomes, it takes in just one parameter, and then that's the parameter that you pass in. That's about it. Everything else is hidden. And you can debug it pretty much the same way, actually. If I go look at it, maybe the console output is not there, but you could look at the console output. It's not here right now because Kubernetes cleaned it up. But if you just ran it, something went wrong, you could look at the console output right here, just as I was looking at the console output over here. But from an end user perspective, it just looks a lot more cleaner. And you have encapsulated all your implementation details from the end user. Okay, let's run this to see that how it works. And I'm just going to trigger this off manually. That's the Git repo. Let me run this. It will run. And while this is running, let me quickly show you how that the Orca local would look like to create something like this. So if you go to this GitHub repo, there is this Orca local.yaml that I have included that you could look at. Hopefully this is not too small. So, these are Kubernetes jobs. There could be other things. Webhooks is, you can create custom job stages, which are webhooks, but Orca also supports jobs. So this is job, the type is Kubernetes, and then, this is the definition of the job. You saw the label as Maven build. You saw the description in there. I just gave it a type. What is the cloud provider? What account to use? Should it wait for completion? This is the parameter that I have defined. And here what I'm telling it is that this parameter maps to the container's environment 0 value. That's what I tell. And if you look at it here, I haven't provided any value, but when it runs, it would provide the value of whatever was passed in this Git repo to this environment, and it would be passed on to the job. So underlying, it runs exactly like the Kubernetes run job that I did, except from an end user perspective, I encapsulated like a custom stage. And if you look at, it includes the spec, which is pretty much the spec that I had in my run job. Why am I saying pretty much? It is exactly the same thing, okay? Hopefully by now this has finished. Yes, it has finished. It's deploying. So if I go look at over here, look at the console output here. And the console output is refusing to come. There you go. It took a little while to get. You can see the output is pretty much like the other one, which we saw, and including the Spinnaker property commit ID coming back in here. Oh, by the way, in this case, this is not exactly a run job. So there is a separate processing through a property file. You have to run it, return it back from a custom stage. Not covering that here right now, but the idea is that you can pass values back for downstream processing, okay? So you saw this got deployed. We didn't make any source code change, so you will not see any changes, but it's the same thing that's running right now. So that covers how you can take a run job that does something like any processing, encapsulate it, and make it available as a custom job stage so that it looks like a Spinnaker stage, not as just a run job. With that, I have pretty much covered how to basically you can use the Spinnaker's run job stage, which runs Kubernetes jobs to do random processing of any scripts, tasks within Spinnaker, and then use the output of that in downstream stages for further processing. Finally, some other considerations. Spinnaker doesn't clean up of the jobs. If your Kubernetes is set up to clean up jobs, that's good. Otherwise, if you don't clean up the jobs, you are left with lots of finished jobs that take up your Kubernetes resources. So if this flag is enabled, then Kubernetes will clean it up. Or otherwise, make sure you either offline have some process to clean up old jobs, or at least use the delete manifest stage in Spinnaker to clean up jobs. The other is around security credentials. Like you saw in Canico, you have to actually create a secret ahead of time and use that. The Git repo that I used for the Maven build and was cloning was open, public, right? So I did not have to pass in any credentials in there. But if I had to have set up either Git credentials on the container or pass it in the Git clone command. So how do you securely, without hard coding the credentials, pass it in? Is something that needs to be considered. Like typically people would have them in some secret store or vault, and then standard Kubernetes secret injection mechanism you can use to make those available in your containers. So that's something to consider from a security perspective when you are using run jobs. With that, I pretty much covered whatever I wanted to cover. Hope you all found this useful. If you have questions on this, feel free to reach out to me at my email, which is nirmalya@opsmx.io. And I'm also available in the Spinnaker Slack channel at Nirmalya Sen. Okay. If there are any questions, feel free to use the live chat, or later on, if you want to reach out to me by email or Slack, absolutely happy to answer any questions. I'll hang around a little bit over here. There is a question here from Champa. Can you limit execution of custom job only to specific fiat auth teams? Yes, you can. The way you do it is limiting the access to the account that runs it, right? I will cover both the job and the run job. So here, configure. Here you're using this account. So the user that's running it must have access to that account, right, to run this. And even when it is a job, if I look at Orca local, I also say what account to use. So the user that's running it must have permissions to that account. And if I go look at Spinnaker RBAC, I think RBAC. Yeah, if you look at over here, here you can give like to accounts either read permission or read write permissions to different roles, and based on that role would either have read permissions or write permissions. So read permissions would allow you to see the infrastructure tab where it's reading, and the write permissions would allow to actually execute and all that. So so to answer the question, that's how you control execution of custom jobs to only roles that are authorized. Hopefully that answers the question, Tom. If there are other questions, I'll happy to answer them. The chat's there. I would be around for a few more minutes. Again, thank you for attending. If you have any comments or any feedback, feel free to direct message me in Spinnaker Slack, or send me an email at nirmalya@opsumx.io, or direct Slack. Or direct message me in the Spinnaker Slack channel.